All right, you guys, for this video, I am going to be talking about the molar mass of compounds lab. So you're going to want to have that up with you. In the molar mass of elements lab, I didn't walk through a lot of problems in this one. I'll walk through a couple more. It's good to see an example. So this beginning part, we're going to get right into it. We're working with a couple of compounds here, calcium chloride and sucrose. I'm going to do the examples for calcium chloride, and then I'm going to have you go back and do the example for sucrose, okay? So for calcium chloride, it first tells you you should look up the formula, the chemical formula. I can tell you on this video, it's CaCl2. For sucrose, you can look it up, but I'll tell you that it's C12H22O11, okay? All right, now, from now on, I'm just doing calcium chloride. Okay, number 2 says make a list of the molar mass for each element in these compounds. So we need to find the molar mass of calcium and the molar mass of chloride, and we do that using the periodic table, okay? So chlorine, 35.45 grams per mole. Calcium, 40.08 grams per mole. So calcium, 40.08 grams per mole. And then chlorine, 35.45 grams per mole. Okay, remember that molar masses always have the units grams per mole, and we always get that information off of the periodic table. Okay, now we're done with number 2 for calcium chloride. You'll have to do that for sucrose. Number 3 says use formulas in question 1 to count how many atoms of each element you have in the 2 compounds. So when I look at the formula, I'm going to see if I can use this pointer thing. When I look at the formula for CaCl2 up here, it's asking me how many Cas do I have? How many calciums do I have? And I just have 1. I know that because there's no little number down here, so that means I have 1. For chlorine, there is a little number down there. There's a 2. That means there's 2 chlorine atoms in that compound, okay? So then when you come back to do this for sucrose, you're looking at how much carbon is in there, how much hydrogen is in there, how much oxygen is in there. Okay, for number 4, it says combine the information from 2 and 3 and calculate the total molar mass of each compound. So we're working with compounds now, and I want the whole molar mass of this whole entire thing, calcium chloride, okay? You might think, okay, let's add together 40.08 because that's calciums, and 35.45 because that's chlorines, and you'd be close, but you're not quite there yet. And the reason for that is that there's 2 chlorine atoms in that molecule. So we need to multiply the 35 times 2, okay? The 40.08 doesn't need to be multiplied by anything, or you can multiply it by 1 to show that you recognize there's only 1 calcium atom, okay? So when we're finding molar mass of a compound, we have to take the number of atoms times the mass for that type of atom. And then when we do that for all the types of atoms in the compound, we can add them all up and get a total. And if you type this in on your calculator, you'll get 110.98. And you're like, well, what units does that have? It's a molar mass, so it has units of grams per mole. But now this means that I have 110.98 grams for every 1 mole of this whole thing, CaCl2. Okay, calcium chloride. All right, that's a quick overview of how to calculate the molar mass of a compound. So not just a plain old element anymore, something that has more than 1 atom. All right, I'm going to scroll down. I think you should do sucrose before you scroll with me. Okay, number 5 says the process of changing from moles to grams is the same with compounds as it was with elements, like we did in the last lab activity. So like we did in the molar mass of elements lab. Imagine that I want you to go to lab and get 0.3 moles of calcium chloride. Remember, we can't get 0.3 moles in the lab because the amount of stuff in a mole looks different for every single substance, okay? So you could say here, different amount of grams per 1 mole depending on the substance. All right, then it says for part B, do a dA calculation that fixes this problem. Okay, so it's telling me I need a dA calculation, so I'm going to have a start, an end, and a conversion factor. Okay, that fixes this problem. What's the problem? Oh, the problem is that I can't mass out 0.3 moles of calcium chloride. So that's my start, 0.3 moles. That's a problem. I need to change that to the units we use in lab. The units that our machinery in lab spits out at us as grams. Okay, so we have to convert to grams. To go from moles to grams, we need a molar mass. And we need the molar mass of the thing we're working with. So we need the molar mass of calcium chloride. We found that right here. Look at that. So the molar mass of calcium chloride is 110.98 grams. Are equal to 1 mole of calcium chloride. Now you just have to do a dimensional analysis problem. So I take my starting value, 0.3 mole, and I need to convert out of moles. So I want to get rid of moles, so I'm going to put my 1 mole of CaCl2 on bottom so that I can get rid of the unit mole. And 1 mole is equal to 110.98 grams. Now all you have to do is math that. So type that in on a calculator. 0.3 times 110.98. Should get something around 33. A little more, a little less. Some decimals in there. And then remember, you canceled out your mole units. So now you just have units of grams. Okay? You should write down an exact answer, not 33. Okay. Then E is talking about use the same process for sucrose. So you're going to set up a similar dimensional analysis problem, but you're going to need sucrose's molar mass here, which you should have calculated up here, okay? Okay, pause and do that now. Down here, it's saying, before you get the sample, predict which pile of chemical will be bigger. You guys could predict based on the numbers up here, which one you think will be bigger. Then it says, now go get the mass of sucrose, or the 0.3 moles of sucrose. I have a picture here for you to look at. You can pause here if you want to look at it for longer. On the left, we have our sucrose, or our sugar. That's 0.3 moles of it. Okay, and on the right, we have our CaCl2, and that's exactly 0.3 moles of CaCl2. So they should be equal, but they don't look equal. You should be able to answer, why does one look like more than the other? Okay, down here it says measure approximately 50 grams of calcium chloride into your weigh boat. I'm throwing out the number that we measured out, 50.54. We did a good job of getting really close. I want you to try to predict based on this number whether that's going to be equal to 0.3, less than 0.3, and greater than 0.3. And you should be able to predict with some accuracy based on that. Okay, it says now calculate the moles of calcium chloride from grams of calcium chloride that you had in 7A. So your start is going to be that 50.54 grams from 7A, and your end is going to be moles. And in order to go from grams to moles, you need to use the molar mass of CaCl2, which you calculated earlier in this packet. Okay, that's going to be your conversion factor. So set up that dA problem. Decide if your prediction was correct. Now it's asking you to do that same process, but this time with, let's do 49.82 grams of sucrose. Okay. All right, make a prediction and then calculate the moles of sucrose from the grams of sucrose. We just said we had 49.82 grams of sucrose. And this is a dA problem, so you're going to have a start and an end and conversion factors. And your conversion factor now is going to be your molar mass of sucrose, or C12H22O11, which you should have calculated on your own earlier in this document. Okay, now we get down to here. It says, do you really get it? Let's check. I ask you to measure out 2.1 moles of sodium bicarbonate for a reaction in lab. If I ask you that question, I'm asking you to do quite a few steps. So it's going to break it down for us, okay? It's asking us to change 2.1 moles of sodium bicarbonate to grams. all right? And you're like, oh, I already see it. It's the DA problem. Start 2.1 mole. And then end is going to be some amount of grams. And then you're like, but what conversion factor do I use? I have to get a conversion factor from grams to moles for this thing, sodium bicarbonate. Okay, so now we break down the steps for you to help you get this conversion factor, okay? So first you need the chemical formula. You can look up the chemical formulas on this document. I'll tell you sodium bicarbonate is NaHCO3. Then it says you need to calculate the molar mass of that whole compound. So there's 1 Na, and the molar mass of sodium is 22.99. And there's 1 hydrogen, and the molar mass of hydrogen is 1.01. There's one carbon, and the molar mass of carbon is 12.01. You can check that on the periodic table. And then careful, there's 3 oxygens here. 3 oxygens, and the molar mass of oxygen is 16.00. Okay, so add all that up to get the molar mass. And then it says now you can answer that problem. So now you should have an amount of grams per 1 mole of NaHCO3. That's your conversion factor. And now you can use this information to answer the initial problem. Okay, now it's a dimensional analysis problem. So start with your 2.1 mole and then fill in your conversion factor. 1 mole of NaHCO3 is equal to how many grams did you figure out in part 2 right here is in 1 mole. And then you got it. Okay, then you've converted, because you cancel out your moles, then you've converted to grams just like you wanted to end in. All right, this last bit is going to ask you to try a similar process on your own. So it wants you to convert 4.5 moles of potassium nitrate to grams, and then 4.5 moles of magnesium chloride to grams, okay? Because you need to decide which one's going to have a higher mass. You can either calculate all the way out to grams, or you might be able to decide earlier than that, but you do need to do a calculation for this problem. So think about what that might be. All right, that's the end of this document with me. I hope this was helpful. If you still have questions, try some things on your own. Watch some earlier videos if you're struggling with DA. Otherwise, send me a message. Good luck.